I'd like to now look at 4 example problems that relate to Taylor and Maclaurin polynomials. So if you could turn to page 8. Example 8, which of the functions graphed in the following figure is most likely to have p of x is equal to 1 plus x minus 2x squared as its second order Maclaurin polynomial, and then you have to explain your reasoning. So first of all, if we have a p of x relates to the y-intercept. So the y-intercept, we have that p of 0 is equal to 1. Since this is a Maclaurin polynomial, we know that we're looking at x sub 0 equaling 1. That's the center. And so p of 0 is equal to 1 by this right here. And then we have p prime of x, and that is equal to 1 minus 4x. So I'm just taking this derivative, right? So if I take this derivative, then the 1 drops out, and the derivative of 1 is x is 1, and then I have a minus 4x. So what this tells me is the slope. So if I take p prime of 0, it comes out that the slope is equal to 1, so it has a positive slope. And then when I take the second derivative, p double prime of x, I get negative 4, and that relates to concavity. So p double prime of 0 is equal to negative 4, so I know that it concaves down. All right, so now I'm going to use a process of elimination. So for p of 0 equaling 1, I know that it can't be this one, right, because p of 0 is equal to 0 on this. For p prime of 0 equaling 1, it has to have a positive slope. So this one is a positive slope, and this is a negative slope. This is a negative slope. So I can basically eliminate this one and also this one. And then I just want to make sure and check this last restriction is met. The concavity should be concave down, and this is concave down. So the correct answer on here would be Roman numeral 2. Okay, turn to page 9, please. All right, so let's look at example 9. It says, suppose that the values of a function f and its first 4 derivatives at x equals negative 2 are f of negative 2 is equal to 5, f prime of negative 2 is equal to 0, f double prime of negative 2 is equal to negative 2, f triple prime of negative 2 is equal to 7, f fourth derivative of negative 2 is equal to negative 9, and then it asks you to find as many Taylor polynomials as you can for f about x is equal to negative 2. Okay, so I'm going to first of all write out the general polynomial on this. And so since it's going up to 4 derivatives, I know that I can take a 4th order Taylor polynomial, right? So this will be the 4th order. So p sub 4 of x equals f of negative 2 plus f prime of negative 2, and then you have to multiply it by x plus 2. So since x is equal to negative 2, it's really x minus a negative 2, which is going to be x plus 2, plus f double prime of a negative 2 all over 2 factorial, or just 2, times x plus 2 raised to the second power, plus f triple prime of a negative 2 all over 3 factorial times x plus 2 to the third power, plus f of the 4th derivative at negative 2 divided by 4 factorial times x plus 2 to the 4th power. Okay, so now I'm going to just substitute in the values and then just simplify. So it says that f of negative 2 is 5. So I'm just going to write 5 here. F prime of a negative 2 is 0. And so this part here will just cancel out. That will just cancel. Right, so that's why I don't have an x plus 1 on this. F double prime of a negative 2 is a negative 2. And so if I put negative 2 in for this and then divide it by 2, that cancels itself out. So I get a minus x minus 2 to the second power. And then f triple prime of a negative 2 is given as 7. So that will be 7 over, and then if I multiply out 3 factorial, you get 6. So it's 7 6 times x plus 2 to the third power. And then f, the fourth derivative of negative 2 is negative 9. And so that will be a negative 9 over 4 factorial, which is 24. So you get 9 over 24 times x plus 2 to the fourth power. So then I just rewrote it and put it all together, and you get this as the fourth order Taylor polynomial. So if you have a fourth order Taylor polynomial, it doesn't always mean that every term is going to be represented. So you can see that I don't have an x plus 2 represented because that just dropped out. Okay, example 10. All right, construct a fifth degree Maclaurin polynomial P. And you're given all of these here. Okay, so to write out the general, and you should always write out the general first so that you know what you're substituting things into. So I have the fifth degree Taylor polynomial, or the Maclaurin polynomial. So that is understood that you're going to have x sub 0 is equal to 0, right? So that's why I just have x, x squared, x cubed, and so on instead of a x minus something. So the fifth degree Taylor, or the Maclaurin polynomial, is f of 0 plus f prime of 0 of x plus f double prime of 0 divided by 2, x squared, and so on all the way to 5. And then I'm just going to substitute everything in. So I have the fifth degree Maclaurin polynomial, and that would be f of 0 is 0, so that just drops out. F prime of 0 is given as 2, so it'll just be 2x. F double prime of 0 is equal to 4, but then that divides with the 2, so that gives me 2. F triple prime of 0 is 6, and then that divides with a 3 factorial because that's also 6, so that you get x cubed. And then f fourth derivative of 0 divided by 4 factorial comes out to be 1/3, because it would be 8 over 24. X to the fourth, and then the final one is 10 over 120, which simplifies to 1/12 x to the fifth. Okay, and then let's look at example 11. All right, let f be a function with derivatives of all orders and for which f of 2 is equal to 7. When n is odd, the nth derivative of f at x equals 2 is 0. When n is even and n is greater than or equal to 2, the nth derivative of f at x equals 2 is given by f of the nth derivative of 2 is equal to n minus 1 factorial over 3 to the nth power. And the question is, write the sixth degree Taylor polynomial for f about x equals 2. Okay, so I'm going to just write out the general first, which is p of the sixth degree polynomial for the Taylor is f of 2, since they tell you x is equal to 2, plus f prime of 2 of x minus 2, f double prime of 2 over 2 times x minus 2 squared, and so on all the way up to x minus 6, or x minus 2 to the sixth power. Okay, so I'm going to now write out each of the powers. So it says that f of 2 is equal to 7. And then it says that f prime of 2 is equal to 0 when it is odd. So all of the odd powers, so that would be the first derivative, the third derivative. So the first derivative, the third derivative, and the fifth derivative, those are all going to be zeros. Why? Because they say it right here. When n is odd, the nth derivative of f at x equals 2 is 0. Okay, so that's how I got that. And now it says when n is even and n is greater than or equal to 2, the nth derivative of f is given by this here. Okay, so now I need to evaluate it. So when n is equal to 2, I have f double prime of 2, and that is equal to, now I'm just going to put in 2 for this. 2 minus 1, that's 1 factorial, all over 3 to the second power, so that gives me 1/9. That's how I get this. Okay, for the next one, it's the fourth derivative. So I'll be putting in 4 for n. So it's 4 minus 1. So that's 3 factorial, which is 6, all over 3 to the fourth power, which is 81. And so that gives me a reduced answer of 2 over 27. And then for the sixth degree, I have 6 minus 1 factorial, which is 5 factorial, and that's 120. And then I'm going to divide that by 3 to the sixth power, which is 729, and then reduce that so that comes out to 40 over 243. Okay, so now I'm going to write out the sixth degree Taylor polynomial. And so I'll have 7. The next one will just be 0, so I don't even write that in. And then I have x minus 2 raised to the second power. And then I need to do the substitution. See, I have a 1/9, but then I also have a 2 from here, right? So 1/9 and then a 2 from the denominator gives me a 1/18. And then in the next one, the third power will just drop out. The fourth power, I have a 4 factorial here. And then I'm going to multiply that by 2 over 27, which gives me 1 over 324. And that's x minus 2 to the fourth power. And then the last one is f of the sixth derivative of 2, I found to be 40 over 243. And then I divide that by 6 factorial, which gives me an answer of 1 over 4,374. And that's x minus 2 to the sixth power.